What's up, Gen Z students? Welcome to this brand new explainer session. I'm stepping in today as your friendly Paya, your ultimate math mentor. Listen, if the word trigonometry has ever given you sleepless nights, I need you to drop that math anxiety right here, right now. Seriously, tension nailinaka. We're going to break down Class 11 trigonometric functions so smoothly that it'll stick in your brain forever. Before we start unlocking these cheat codes, do me a solid. Smash that like button and subscribe to this study channel to support this series. Ready? Let's get into it.
Here is our ultimate mind map for Chapter 3. We'll be covering 1. Trigo ki nai shuruat. 2. Looking at angles from a fresh perspective. 3. The radian and degree connection. 4. The unit circle concept. 5. The logic of quadrants and signs. And finally, 6. The sum and difference formulas. All right, let's dive right in.
Okay, Part 1. Trigo, ek nayi shuruaat, transitioning from Class 10 to Class 11.
So, I know you guys tackled basic trigonometry and triangles back in Class 10. But here's the deal. We are leveling up now. We aren't just looking at right-angled triangles anymore. We're shifting to treating trig as dynamic mathematical functions. And to do that, we need to completely rebuild our understanding of an angle. Let's take it slow and steady so this is crystal clear. An angle is basically just a measure of rotation. You only need three things: a vertex, which is your fixed anchor point, an initial side, which is exactly where your ray of light starts its journey, and a terminal side, the spot where the ray finally stops after rotating.
Look how visually simple this actually is. See that vertex O? That is our pivot. The ray starts flat on the initial side, OA, and then it sweeps open, rotating until it literally stops at the terminal side, OB. That empty space it just swept through, that's your angle. It's not just a static shape, you guys. It's an action. It is a rotation.
Moving on to Part 2. Angles ko naye nazariye se, or positive and negative rotations.
It's time to look at angles with a totally fresh perspective. As your mentor, I'm guiding you into some new territory here. The idea is that an angle isn't just a flat number. It actually has a direction. If your initial side rotates anti-clockwise, meaning it sweeps upwards or upar ki taraf, that creates a positive angle. Pretty simple, right? But if it sweeps downwards, moving clockwise, niche ki taraf, exactly like the hands of a wall clock, it creates a negative angle. Let that sink in for a second. The exact same amount of rotation gives you a minus sign literally just because it went downwards. Kind of mind-blowing, right?
Now, I've got a quick interactive question for you to see if you're tracking with me. Ek pura chakkar kitne degree ka hota hai? Like, how many degrees are in one full, complete revolution? Drop your answer in the comments right now before I reveal it. Go on, I'll wait.
Okay, if you typed 360 degrees, you absolutely nailed it. When a ray does one full revolution, sweeping all the way around until the terminal side lands exactly back on top of the initial side, it has traveled exactly 360 degrees. And you can keep spinning it like a Beyblade, making it 720 degrees, 1080 degrees, going all the way to infinity in either the positive or negative direction.
All right, Part 3, radian or degree ka connection. The real star of Class 11.
Say goodbye to degrees being the only boss in town. Let me introduce you to the radian. This is the absolute real star of Class 11 math. Now, don't let the name intimidate you. It's literally just a different, honestly much more powerful way to measure that exact same rotation we've been talking about. But before we fully pivot to radians, let's look at the microscopic breakdown of a degree. One single degree is just one tiny slice out of 360 in a full circle. But did you know we can slice that single degree even further? 1 degree equals 60 minutes, and 1 minute equals 60 seconds. Now, a playful warning from your Baya. Please do not confuse this with the clock on your wall. We are talking about microscopic slices of an angle here, not time. And this brilliantly illustrates our basic funda. It's the ultimate bridge between the old world and the new world. One full circle, which we know is 360 degrees, is exactly equal to 2 pi radians. If we cut that in half, we get the golden rule you absolutely must memorize. Pi radian equals 180 degrees. Radians let us link angles directly to real numbers, which is going to be a total superpower later on. Okay, here is a pro study tip just for you. Consider this your 2-step cheat code for exam prep. If you have a radian measure and you need a degree, you just multiply it by 180 over pi. And if you have a degree and need a radian, you multiply by pi over 180. Honestly, write this on a sticky note and slap it on your desk. It is that important.
Moving right along to Part 4, the unit circle concept, where geometry meets trigonometry.
If you're ever feeling a bit lost, just remember this really simple fact. A unit circle is literally just a standard circle where the radius is exactly 1. That's it. Nothing crazy. And it is about to make trigonometry incredibly visual for you. Imagine a point P moving along this circle. Because the radius is 1, the x and y coordinates of that point, let's call them a and b, literally become your trigonometric functions. The x-coordinate a is simply cos x, and the y-coordinate b is simply sin x. Just like that, sine and cosine aren't abstract formulas anymore. They're literal coordinates on a map.
And because it is a map, let's apply a classic rule to it. You guys remember the Pythagorean theorem for right-angled triangles, right? Base squared plus height squared equals hypotenuse squared. Well, in our unit circle, that is, a squared plus b squared equals the radius squared, which is 1. Substitute our new coordinates in, and boom, magic happens. Cos squared x plus sine squared x equals 1, the most famous trigonometric identity in the world, born directly from a simple circle.
Awesome! Part 5. Quadrants or signs ka logic. Cracking the code of plus and minus.
I am actually really hyped for this one, because this is the ultimate hack for figuring out whether a trig function is positive or negative. Pro study tip, screen grab this table right now for your exams. Seriously, take a screenshot. The logic here perfectly follows our unit circle coordinates. In the first quadrant, both x and y are positive, so everything is positive. In the second, x is negative, but y is positive, so only sine and its inverse, cosecant, are positive. Just remember the classic trick. Add sugar to coffee. All sine, tan, cos. It tells you exactly who is positive in quadrants 1, 2, 3, and 4.
And here we are, Part 6. Sum or difference formulas. The final boss level.
Now I'm going to be totally honest with you guys. These look scary, like a giant wall of alphabet soup. But as your mentor, I am telling you they are totally manageable if you just spot the hidden patterns. Let's look closely. For cos of x plus y, the pattern is cos, cos, sin, sin. But the trick is, the sign flips. A plus inside the bracket becomes a minus outside, and a minus becomes a plus. Now look at sine. Sine is friendly, it likes to mix things up. Sine, cos, cos, sine, and it keeps its original sign. Plus stays plus. Spotting these little behaviors makes memorizing them an absolute breeze.
And finally, the sum to product identities. These are derived straight from the previous ones we just looked at. Notice how adding 2 cosines gives you pure cosines on the right side, and subtracting them gives you pure sines with a sneaky little negative sign right in the front? I promise you, write these down 3 times, try a few practice problems, and these massive equations will just become second nature to you.
अब जब base strong है, तो सोचो, now that your foundation is rock solid, think about this. How will mastering these exact trigonometric patterns unlock your true potential when you tackle advanced JEE physics or intense calculus next year? Because trust me, this unit circle and these formulas, they are the literal keys to the entire kingdom of higher math. Keep practicing, keep visualizing the concepts, and stay confident. You've totally got this. Don't forget to like this explainer session, drop a comment with any questions, and subscribe so you don't miss our next masterclass. Until next time, keep learning.